Well, a day of transition dawns today. We've got beautiful summertime conditions again. We had a dew point of almost 60 yesterday. I don't know what the record earliest 60-degree dew point in Madison is, but we must have been darn close to that. Beautiful summery morning today, but it's going to give way to some thunder activity and some reasonably wet conditions beginning late this afternoon and probably going on and off all the way through the rest of the week. So it's going to be kind of a unsettled and rainy week for the rest of the way out. And this is our map this morning at 8:15 local time. I want to draw your attention to 4 or 5 different disturbances on this map that we'll pay attention to when we get to the 500 millibar map. Number 1, there's a cyclone to the southeast of Nova Scotia off the east coast of the United States. There's a region of high pressure that's sitting over the southeastern United States, kind of disjointed a little bit in this analysis, but broadly speaking, a region of high pressure sitting over the southeast U.S. The obvious impending region of low pressure that's going to affect us is sitting just to our southwest over southwestern Iowa and putting itself together, and you can see some of the radar echoes we'll look at in more detail in just a second. Then there's a region of high pressure sitting just about over the Salt Lake, and then another region of low pressure coming in from southern British Columbia into Washington State. So those are the 5 different features: low, high, low, high, low, across the continental United States and adjacent waters this morning. And you'll see that pointed out again in just a minute. So being on the eastern side of this cyclone as it's getting itself organized in the central U.S., that means, given the counterclockwise flow around these storms in the northern hemisphere, we are the beneficiaries of southerly winds coming from the south with a reasonably strong clip. This pressure gradient distance between the successive isobars is not, really weak as it is over the southeast. It's not as strong as we've seen in other cases, but it's going to give us a persistent southerly flow all day long today. And you'll see, based on what we have for observations of temperature and dew point at those places furthest to our south and west, that's going to be a continued supply of warm, moist air all during the day, unsurprisingly, given the circulation around the storm. So let's take a look at the temperatures now. Remember, our storm is right about here, right about over Kansas City, so we're on the eastern side of that, and these temperatures are quite warm. This is, again, 8 a.m. local time. Mid-60s to low 70s across Texas and parts of the Arkansas, Louisiana, Mississippi. We're in the low 60s as far north as Chicago. 57 here at Madison. It's hard to complain about that. And then right past remember the cyclone's right about over Kansas City, and there's an evolving cold front trailing to its south, and the temperatures drop off quite dramatically. It's 70 in Dallas. It's only 39 at Amarillo, 41 at Lubbock. So that's a really sharp temperature contrast, and much of it's actually concentrated much closer to Dallas than it is to Lubbock. So, and the same is true just across the river, Missouri River, from Iowa to Nebraska. You're in the 60s broadly in the state of Iowa, but then Omaha has 47 just across the river. So it's much colder behind the cold front. And we'll see also that's reflected in the moisture content. Look at the dew point contrast across Iowa. In the mid-50s, high dew points, very warm, moist air, but then bone dry when you get across the Missouri River into Nebraska. And by the time you're in the high terrain of western Nebraska, the dew points are in the low 20s. Look at this contrast across Texas. 63-degree dew point at Dallas, 32 at Lubbock, 30 at Amarillo, and probably in the low 40s everywhere in between. So this is a very sharp, characteristically sharp dew point contrast. Sometimes it's known as the dry line in the desert, in the southwestern plains. It's a really sharp feature. But we are, of course, in line for a continued supply of warm and moist air, because this is where the air is coming from today. As you know, the circulation around the cyclone is pulling air from the south on its eastern side, and so we're going to stay warm and moist during the day today, so it'll feel summery all day long. Here's the satellite movie for the last several hours, and you can see this circulation center in western Kansas getting itself nicely organized over a period of time, and some of this line of cloudiness, which occasionally erupts with convection, and we'll see that in the radar in a minute, is the kind of weather that we're in the running for as the day wears on and we move into the next day. So that's one feature. That's the cyclone in the central U.S. Here's the cyclone south of Nova Scotia in the satellite movie. Really expansive circulation, but clearly counterclockwise, and now, of course, we know why. And a bias for the clouds to be on the eastern side, and we know that now, too, because that's where all the warm frontal activity is. And so the warm frontal structure provides cloudiness on the eastern side of extratropical cyclones in the northern hemisphere. Here's the disturbed weather that's coming into Washington State. So that's the next cyclone. So there's cyclone 1, 2, and 3 in between over the Great Salt Lake, a region of high pressure. Naturally, it doesn't show itself in clouds because high pressure regions are characterized by upper convergence and the air sinks, and so the clouds are evaporated away. The same is true over the southeastern U.S. So the absence of clouds here testifies in some way, but only to the tutored mind, that there's an anticyclone in those locations. Okay, so we'll keep that in mind as we move forward. And we'll look at the radar across the continental U.S., and you can see here's the really interesting radar reflectivity across Missouri, moving into Iowa, right at the front edge of this, just about getting to the Wisconsin border near Platteville. You can see some of these cells erupting with orange and red in them. Those are thunder showers, and that's what we're going to see later on this afternoon. And it'll be occasional. You'll get a downpour and some thunder and lightning, and then maybe a little bit of clearing, or at least a cessation of the rain, followed by yet another shower as the rest of this storm and its frontal structure kind of moves through during the next couple of days. Here's the warm frontal structure for that cyclone. It's well to our north, and so it's providing some light to sometimes occasionally maybe downpourish type precipitation across the northern coast of the Upper Peninsula. Okay, so that's really the main precipitation feature across the United States today, and it's going to affect us. So let's take a look now at, again, the 500 millibar map torn from last night's weather. I never get the 7 a.m. update in time for class, but this is last night's 500 millibar map. We're back now to the one that's constructed in our own department. It's a little bit easier to read. But you can see the black lines are like isobars at about 5.5 kilometers above the ground. So where they're tightly spaced, the wind speeds are very large, like here over the Kenai Peninsula of Florida. I mean, Alaska, completely the opposite of Florida. Alaska, 80 and 90 knot winds are indicated here. And notice all the wind arrows are parallel to the black lines, as they have to be, because at this level, the flow is pretty close to geostrophic. That's true also around this strong trough that's over Colorado and New Mexico. The flow is pretty much parallel to it. Then there's a big ridge that's just to our east. The ridge axis is just to our east, I'll point out in a minute. And you can see the flow is parallel to that ridge axis and very weak. Look at the Green Bay wind, only 10 knots at 3 miles above the ground. That's pretty weak wind. But the pressure gradient force, by virtue of the distance between these successive isobars, is very weak, probably the weakest part of the whole map, or one of them. So here are the series of trough axes that you can identify, one running right through this trough just to our west, one off the west coast of the United States, and then heading into this cutoff disturbance. And then the cyclone southeast of Nova Scotia is tied up in this really strongly cut off upper level low, but that's really still a trough axis. And then the ridge axes are in between the trough axes. Here's an obvious ridge axis. Notice the poleward protuberance of the equivalent isobars in the black lines going poleward along that line and going poleward again along this line, cutting through California and eastern Oregon. And if we try to put the vorticity on here in a cartoonish version, here's where the positive or cyclonic vorticity is going to be, is associated with the trough axes, and downstream to the east of those vorticity features is where the surface cyclones are. Remember, there was a cyclone off the coast of Nova Scotia. There was a cyclone right over Kansas City and or along the Missouri River there between Iowa and Nebraska. And there was a cyclone invading over the Pacific Northwest. And they're all in association with upper level regions of positive vorticity. And so the cyclones are in regions of positive vorticity advection. Here are the ridge axes highlighted with the negative vorticity features that are associated with them. And here are the anticyclones that follow downstream in the regions of negative vorticity advection. There was an anticyclone over the southeast U.S. There's another one set right about over the Great Salt Lake, and they just sit perfectly where they belong. And so there's our trough, ridge, trough, all the way across the continental U.S. And to the east of each trough, there's a region of low pressure at the surface. To the east of each ridge, there's a region of high pressure at the surface. Perfect relationship. Again, pulled at random from today's weather map. You know, you can't make this stuff up unless it were true, and it is true. It's robustly true. So that's kind of a nice thing to look at every day. And then here's the West Coast satellite movie across the western portion of North America and then into the central and eastern Pacific. Kind of a boring weather map today. There's not really anything particularly well organized, although one does see a counterclockwise rotating collection of cloud elements to the northeast of Hawaii and well off the coast of California, but that's not really a well-organized storm. Here's that storm that's invading the Pacific Northwest now that was associated with the upper trough that I identified on the 500 millibar map. There are more extensive developments occurring well to the west, one of them at about the dateline or even east of the dateline, that west of the date line. That's really looking quite impressive. Maybe we'll see some of that on Friday. But that's the way the weather looks today. And I hope you're, as I say, I said yesterday and I say it again today, trying to get you to think about how all of the stuff you're learning in this last section of the course brings together so many of the elements of the rest of what we've talked about all semester long, but brings them to a whole new level. And I'm hoping that you're finding that interesting and enlightening.